practical. In this practical, we will find exact solution of first and second order ordinary differential equation using desolve at value built-in function of maxima. We already solved practical 5th where we solved the first order and second order differential equation. So to find the solution here, the syntax is desolve, here simple bracket and this is close bracket. Here you will write the label of your equation which you want to solve, then comma, and here you will write the square bracket and there is a dependent variable. You can use this for more equations. In our practical, we will solve first order and second order differential equation only. And the logic here, desolve syntax function use his Laplace transform. The logic is Laplace transform, and here the value of y, this is initial value problem we will solve here, and for this at value function is used inbuilt function. This is in Maxima, and we will assign this value of y at x equal to a, and this is the syntax to write the value of y at point a. So syntax is at value you will write, and here you will write your expression, that is your y, and x is equal to a. This is value of independent variable, and value of your y, yani ki dependent variable at this point is assigned here c. For example, I will solve here this differential equation. This is my dy by d of x plus yx is equal to 0. It's initial value problem, and when x is equal to 0, this one value of y is 1. So this initial value is used to find the constant c. So let us first enter the differential equations. As I told you in my previous lectures, how to enter a differential equation. This is my differential equation in input value 1, and it is dy by d of x plus y of x is equal to 0. It is first order differential equation with constant coefficients, and the right hand side is 0. Now first of all, tell me the complementary function for this differential equation. Particular integral is 0 here, and when you write this in the d plus 1 operating on y equal to 0, the value of d is minus 1 here. The solution complementary function here is constant c e की power minus of x. Okay, now you want to find this constant value, and first of all manually you should solve this question. Okay, so first you will find the constant c. To find this differential equation by desolve and the constant c here, I'm not using IC1 function. I will use desolve and at value inbuilt function here. So first of all, enter the initial values of your dependent variable in the memory of this software computer. Okay, so here x is equal to 0, this is, and your dependent variable here is y. So you will write this syntax here, at value simple bracket, you will write your dependent variable which is y of x, comma, its yx value is equal to 1. This 1 is shows here value of y, and this value of y is when x is equal to 0. So I am entering this. When I enter, this shows that you have entered value of y is 1 when x is equal to 0. Now solve this differential equation. This is your syllabus. So constant is here 1. So e की power minus of x, यानी exponential आएगा, and then you will calculate the constant values. So here you should check this label. Here output is 4. If I enter this, it will shows me the error because desolve percent is 0 1. I will write this is equation number 4. So you will enter it, shift and enter. There is a mistake here. This is considering equation number first is another. I want to find the solution of this differential equation. First I will quit it and start it again. So I will write the quit command first and I will run the my command again, so that I will enter this line should be input value 1. So look at here, this is input I1 and I enter here differential equation dy by dx plus y of x is equal to 0. Now entering the initial values. So here is output 2. You should check the label also whether your output is running properly or not. Now I am using this. I got this information because it is giving me the 2 roots, but my differential equation is of order 1 and here the roots value d is -1. So the complementary function will contain the power e की power -x. But here I am getting this one. It shows that it is not running properly. Now look at here, my differential equation and desolve command, I will use it first. Shift enter. So it shows the exact answer. So this is my particular solution for this differential equation with this initial condition x at 0, value of y is 1. Now to find the solution of ordinary differential equation of second order, so again you have to enter first the differential equation of second order. I have already taken this differential equation. This is d square y by dx square plus 4 dy by dx plus 3y of x is equal to 0. First you will solve this manually and I am entering here y at 0 is equal to 0 and also y dash, look at here, this is differential of yx with respect to x and its value is 12. So how to enter? Shift and this at value bracket simple start. You have to enter the expression that is y dash at 0 is equal to 12. So this is syntax to write this in the memory of MAXIMA Software. Now I want to solve this. So my differential equation is at position 4. So you will write desolve simple bracket. As I told you the syntax. Look at the syntax of this one. In examination, we will ask you what is the syntax to write this desolve command here. So the syntax for this is desolve equation. This will be right. You should write this in the square bracket. Remember this thing. So I am writing this here. The syntax for this is desolve so you should remember this one, desolve this inbuilt function simple bracket and then close bracket. You will write the label of your equations. I enter my second order differential equation at output 4. So you will write desolve simple bracket percent 04 any output 4 comma and in square bracket you will write the dependent variable. So enter this one. The answer is 6% e की माइनस एक्स यानी कि आपके जो रूट आएंगे इस इक्वेशन में डी स्क्वायर प्लस 4d plus 3. The answer is roots are -1 and -3 and your constant c1 and c2 obtained is 6 and -6. You can practice your here देखिए your right hand side is 0. You can practice more differential equations of second order with constant coefficients. You can enter the variable coefficient also. A variable coefficient I will discuss in the next part. So again I am entering a differential equation, non-homogeneous differential equation whose right hand side is 5 of x. Again you will enter the initial conditions. Now you have to tell me what are the initial conditions. देखिए यहाँ पर x is equal to 0, the corresponding value of y is -1. So y at 0 is -1. You are entering this initial condition in the memory of computer. And again the second condition is differential of yx, यानी कि y dash at 0 is equal to 2. When you apply this, now tell me the differential equation label. This is output 8. If I enter 18, it will shows me some error. The reason is, why it is showing me error? Because I am entering here equation label is output 18, but I enter my differential equation at output 0, output 8. यानी आपने enter 8 पे किया है, तो you should write here the exact location of your differential equation which you want to solve. So this is your answer. Here this 5x by 9 plus 50 by 81, it is your particular integral, and your differential equation is with these initial conditions, that is 31 e की power 9x by 18 minus 2 e power x. Okay, thank you so much for watching.